So let me use this example, t squared plus 1, to discuss average velocity and then instantaneous velocity. Suppose we have an object moving along a straight line with the information. The displacement is t squared plus 1, where t measures the time. So average velocity, well, is distance over time. So quite straightforward. So if you calculate average velocity of the object between t equals 1 and 2, well, distance over time. So to find the distance, you need to use this displacement. Well, this function tells you the location of the object. The distance between two positions is exactly the distance between two function values. So average velocity is going to be distance over time. The time difference is 2 over 1. So this should remind you of the previous expression. So we used the similar expression for slope of line joining 2 points. Actually, this average velocity is nothing but the slope of the line L. So this is slope of the line. So when you take interval from 1 to x, then the average velocity is quite similar. So the distance between 2 points is f of x minus f of 1 over time difference. Doesn't it look similar to the previous expression? The slope of the line joining 2 points P and Q. When you use interval using h, so when you take, say, point x here, then this x can be written as 1 plus h. So in that case, the distance is going to be f of 1 plus h minus f of 1 over time difference, which is simply h. And again, when you take limit as x approaches 1 or as h approaches 0, you will get instantaneous velocity. You simply take the limit. So instantaneous velocity is going to be the limit of the previous expression. Let me replace this number by some generic number a. And similarly, equivalent definition is f of a plus h minus f of a over h. So instantaneous velocity is nothing but the limit of average velocity as x approaches a or h approaches 0. So slope of tangent line has different equivalent meaning. So when it comes to physics, slope of tangent line gives you instantaneous velocity as well. All right, here's a quick example. Let me use the function t squared plus 1 again to find instantaneous velocity of the object at t equals 1. So our object moves along the straight line, and the displacement is given by this function. So for example, when t equals 0, we have 0 plus 1. So the position is 1. Okay, so by definition, instantaneous velocity is the limit f of t, or x minus f of a over t minus a, t tends to a. I'm repeating the definition. So f of t is t squared plus 1. And then our a is here, minus f of 1. When you plug in 1, we have 1 plus 1 over t minus 1. So basically, we want to calculate limit of this expression. Well, again, if you plug in 1, we have 0 over 0. And you want to find some common factor and cancel. If you simplify this, we have t squared minus 1 over t minus 1. So as we did, this t squared minus 1 has a factoring, or it's t plus 1 or t minus 1. That's it. Once you cancel common factor, you can find the limit. So it turns out that instantaneous velocity of the object at t equals 2 is 2. Actually, this calculation is the same, exactly the same calculation that we had in the very first slide. We are using x squared plus 1. So I'm using this same example to emphasize that slope of tangent line is basically the same to instantaneous velocity. Another example, our function is 2 over x minus 8. We are interested in tangent line to the curve at point. We are given a value 10, x equals 10. When you plug in 10 here, we have 2 over 10 minus 8, or 1. So we have good. And to find the tangent line at this point, we need to use the limit. So let me repeat the definition. Limit of f of x minus f of a over x minus a. Our function is 2 over x minus 8. Our function value is 1. X minus, of course, our a is 10. This will give you 10. And then we take limit. If you plug in 10, we have 2 over 2 minus 1 over 10 minus 10, or 0 over 0 form. So we need to find common factor and then cancel. Okay, so common denominator is x minus 8. So this one is going to be x minus 8 over x minus 8. So that's why we'll have x minus 8. But be careful with the sign. Now that we have negative, we need to put parentheses with this negative. So be careful with this sign business. Over x minus 10. Good. If you simplify this, we have, well, negative x, negative, negative, or plus. So you want to cancel common factor and simplify. Well, if you put this silly denominator, you see the structure. And as we did, we can cancel the common factor as long as they are in the same position. Two expressions are the same up to sign. So they differ only by the sign. So when you cancel, we will get negative 1 over x minus 8 over 1 over 1. We are ready to find the limit just by plugging in 10. Well, negative 1 over 10 minus 8 or 2. it turns out that slope of the tangent line is negative 1/2. And you want to write down the equation as well. We can use a point slope form. Y minus y value, or 1, slope x minus x value. So we are using point slope form. Okay. Next example is also quite similar to previous one, because look at the function. 2 over t minus 8 is the same function, 2 over x minus 8. I just changed the letter x by t. So the remaining calculation will be the same as before. So the reason I put this example is that, again, instantaneous velocity is basically same to the slope of the tangent line. So this is slope of the tangent line, which is exactly same to instantaneous velocity of the same function. So the same as above. Or instantaneous velocity is exactly negative 1/2.